So the second page of the review, we're going to start by graphing a piecewise function. Remember, a piecewise function is just that. You've got different functions, more than one function, and you have a restricted domain for each function. So what we're going to do, first of all, is we're going to just create a table of values for each part of my piecewise function. Now remember, when you're graphing a piecewise function, even though this states x is greater than 0, you always start with the x value where the domain gets restricted. And you're just going to fill in a couple x values, like 0, 1, and 2. Plug them into the function, so -4 times 0 is 0, -4 times 1 is a -4, and -4 times 2 is -8. Now since 0 is not included in this domain, it's just a boundary point, this 0, 0, I'm going to represent graphically by an open circle. So here's my point 0, 0 with an open circle. 1, -4, 2, -8. And again, we know that -4x is just a straight line. So again, that's what the graph -4x for x value is greater than 0. Now you've got this other thing. It's just a single y value of 4. It says x equals 0. That's a point 0, 4. So again, I'm just going to graphically represent that as a point 0, 4. So again, this is how when you see a piecewise function, you see a point. So again, next thing is x squared plus 1. So I'm going to make another table of values, and again I'm going to fill in x values that are less than 0. So I'm going to start with 0 and -1, -2. Plug them into my function. 0 squared plus 1 is a 1. -1 squared is 1 plus 1, which is 2. -2 squared is 4 plus 1, which is 5. Again, x less than 0. 0 is not included in the domain. This is just going to be a boundary point at 0, 1. So I'm going to put an open circle there. Then I have -1, 2, and then -2, 5. And again, this is a parabola, so we know it's a U shape. So that's what that particular piecewise function looks like. So now for the domain, again, you pretty much have the domain right here. All real numbers greater than 0, all real numbers less than 0, and we're actually including 0. So the domain is going to be all real numbers. Now range. If you look at the graph, notice the graph is coming from -infinity to 0. But then notice there is a break. 1 is not included in the domain. So you have to split the range from -infinity to 0, and then from 1 to infinity. Limit. So the limit is x approaches 0 from the, and that is a plus sign, I think, yeah, 0 from the right. So again, as you're approaching 0 from the right, again, you can use your graph or you can use your equations. As we're approaching 0 from the right, the y value that you're getting really close to is 0. The limit as you're approaching 0 from the left. So if you trace your graph as you're approaching 0 from the left, notice you're getting really close to a y value of 1. Now remember, the limit as x approaches 0. This is your two-sided limit. Remember, for this to exist, what happens on the right has to be equal to what's happening on the left. And notice they were not. If you trace your graph, notice your fingers do not meet at the same point. So therefore, this limit does not exist. So now the limit as x approaches 5 from the right. Remember, you can always do limits by direct substitution. Remember, we say, this is -5. So again, we know that -5 is less than 0. So I can just do a direct substitution, plugging -5 in for x. So -5 squared plus 1, that's going to give me 25 plus 1, which is a 26. Now these are not asking you about limits, these are asking you what happens at a particular x value. So -4 fits into what domain? Well, -4 is less than 0. So I can plug -4 in for x, so -4 squared is 16 plus 1 is 17. Where is x equal to 0? That's that point I plotted, and the y value is 4. When I plug in a 4, I know that 4 is greater than 0, so I'll plug negative 4 in for x, so negative 4 times 4 is 16. So then we also talked about the transformations of parent functions. So remember the minus 3 under the square root. We're going to take that parent function and go to the right 3. And then we're going to go up 2. So again, if you think about, again, when you want to find these limits in the domain, even though it's not asking you to graph, think about your square root function. We shift it to the right 3 and up 2. That's what a sketch of that particular graph would look like. And the limit as x is going to infinity. Remember, it's looking at n behavior. So the n behavior on the right-hand side, that's going towards positive infinity. The limit as x is approaching 3 from the right. Well, as you're approaching 3 from the right, if you take a look at the graph, as you're approaching 3 from the right, you're getting really, really close to 2. Or what you could do is just do a direct substitution and plug 3 into this equation for x. And notice 3 minus 3 is 0, square root of 0 is 0, and 0 plus 2 is 2. Same thing here, the limit as x approaches 12 from the right. Do a direct substitution, plug 12 in for x. 12 minus 3 is 4, square root of 4 is 2, and 2 plus 2 is 4. So domain is talking about the x values. Notice the graph has the graph starting at an x value of 3 to infinity. So it's going to be bracket 3 to infinity. The range is 2 to infinity because I shifted it up 2. So notice the transformations here. With a negative sign, I reflect over the x-axis. I have a vertical stretch by a factor of 1/3. I'm going to the right 2 and up 4. So even though the question's not asking me to graph, I know I'm going to be reflecting this graph instead of the parent function going like this, with a reflection over the x-axis, it's going to go like this. And then I need to shift it to the right 2 and up 4. So the graph then is going to look something like this. The vertical stretch or compression is not going to affect the domain or range. It's just affecting how flattened out the curve is. So the limit as x goes to infinity. So as I'm going to infinity, I'm looking at the n behavior. And notice that graph is now going down to negative infinity. The limit as x is approaching 2 from the right. Again, I can do a direct substitution. 2 minus 2 is 0. And I know negative 1/3 times 0 is still 0. 0 plus 4 is 4. Again, when I plug in 6, limit as x approaches 6 from the right. 6 minus 2 is 4. Square root of 4 is 2, so that's going to give me negative 2/3 plus 4. So that's going to give me 3 1/3. Or as an improper fraction, that would be 10/3. The domain, because I shifted it to the right 2, is going to be bracket 2 to infinity. The range is going to be from negative infinity to 4. So even though the question didn't ask you for a graph, really to do the domain and range, you really needed to have an idea of what a rough sketch of that particular parent function is going to look like.